This lesson is all about the mechanics involved in throwing exceptions. You can throw them yourself in your own code, and some are thrown by the system. And you have to handle checked and unchecked exceptions differently. Let me start with a simple example. The main method creates an instance of itself. Then it prints this line stating that it's about to call the method of the class. Then it calls the method and then finishes up by calling a line stating that it has called the method. The method first prints a line that it's about to perform a division operation. Then it divides the number 5 by 0. And you know that won't work. But after the division, another line is printed that the division has been completed. Now, here's what's going to happen when this program is run. The first print statement in the main line will output a line of text. Then the method will be called, and the second line will be output, the first one in the method. Then comes the division by 0. At this point, the system will throw an exception, which means that the current location of execution is abandoned, and the exception causes an immediate return from the method. The second print line of the method then doesn't happen. In the main method, the divide by 0 method comes back with an exception. The exception isn't handled here either, so the throw continues. It's thrown to the caller of the main method, which throws it smack into the Java virtual machine where it's handled. The program has been exited and is no longer running, but the exception is still in the hands of the JVM, which displays its contents. It looks like this. Here you see where the two printed lines came from inside the program, but once the exception was thrown, we quit hearing from the program altogether. Now, that's an important point. Once an exception is thrown, nothing else happens in your program unless you specifically do something about it. Exactly what you can do is shown in the next lesson. The information held inside the exception is quite useful when it's printed out this way. The top line here explains the reason for the exception being thrown by including the class name of the exception object itself. If you don't know, you can look up the name in the documentation, and it will tell you why this particular exception can be thrown. The next line tells you exactly where the exception was thrown. It came from line 12 of throwing1.java. The rest of the lines are a full traceback of how the program got there. Here, let me show you. This program is just like the previous one, except it makes method calls a few levels deep to get to the method that throws the exception. But once the exception is thrown, it keeps going back up the chain looking for a place that the exception is caught. Here's what the final output looks like. There you see a complete list of the method calls. In a large program, this list can get quite long, but it can be very valuable in debugging. Lots of times you'll see some system methods listed in among them, but it always ends up where the actual exception occurred. Okay, so much for the system-thrown exceptions. You can create and throw your own. It's just a matter of creating the throwable object and then using the throw command. Here you see where the new throwable object is created. All of the exceptions have constructors that allow you to specify a string description of why the exception was thrown. Now this one is claiming that it's being thrown because of a divide by 0, but that never actually happens. You can throw an exception anytime for any reason. And once it has been created, you can throw it with a single command. Now actually there's no need to store the address of the throwable in a reference this way. Usually they're thrown as they are created, and I'll show you that here in just a bit. Right now, let's just run this program. Here you see the results. The string specified in the program is the one printed in the traceback. Now, the truth is that these messages are not always this clear. You'll see some that make you stop and try to figure out what the devil the programmer was thinking about when he wrote it. Throwing a checked exception is about the same, but you have to tell the compiler that it's okay. Now this class has a method that throws a checked exception. That is, the compiler checks and makes sure that you either catch it or that you pass it on up the chain for the next guy to catch it. Here is where the exception object is created and thrown. This is the exception that's normally thrown when an interruption occurs, but I'm just using it as a demo of throwing a checked exception. Look right here. Because the exception is not being caught in this method, it is being thrown to its caller. But it's checked by the compiler, so you have to specify that this method may throw the exception. But the main method doesn't catch it either, so it will throw it. But this is a checked exception, so it must be declared that this method may throw such an exception. If you haven't worked with exceptions before, I suggest that you play with this program just a bit. Take out the throws clauses and see what sort of error messages come out of the compiler. You'll find that it's very handy when you do things this way. You can just code right along and not worry about exceptions and just wait for the compiler to tell you which ones you need to handle. When you get a clean compile, you can be sure that you've explicitly handled all of the things that you need to handle to take care of exceptions. In the next lesson, I'll show you how to catch and handle the exceptions.